So this is Unit 3KA. Okay, so a row is a rectangular array of, oops, I'm sorry. I don't know why I said row. A matrix is a rectangular array of numbers. Okay, and what that looks like is something like this. Or it just has numbers in it. Okay, a number in the matrix is called an element. So those numbers, like that number 7, are called an element. Number 3, only matrices of the same dimensions can be added or subtracted. So that means if this matrix here is a 2 by 3, meaning it has 2 rows and 3 columns. And this one is also a 2 by 3. So again, it has 2 rows and 3 columns. Then you can add or subtract them. So let's look at an example here. Well, this has 2 rows and 2 columns, so does this one, so we can go ahead and add them. And adding them isn't too bad. Okay, you kind of like follow their position, so -3 and 0 get added together. So that equals -3. Then the 2 and 5 can get added together, so we get 7. And then we have 0 and -1, which is -1, and then 4 plus 6 is 10. So that would be this one. Okay, so similar to subtracting, make sure they have the same dimensions, which they do. And we kind of do the same process, right? 9 and 0 can be subtracted, so that gives us 9. -5 minus 1 is -6. 3 minus a -4 is +7. 7 minus 2 is 5. So that would be this last one. Okay, so multiplying. So multiplying is a little bit different. You do have to check the dimensions. So the first one is a 2 by 2. The second one is a 2 by 2. The columns in the first one need to match the rows of the second one. And if they do, you can multiply them. Okay, so the way we are going to multiply them, we're going to drop that first matrix. So 1, 0, 3, 2. And then we're going to have this one at the top. Okay. And so what we're going to do first, we're going to focus on row one of the first matrix. And we're going to multiply it with column 1 and column 2. Okay, so we're going to take 1 and we're going to multiply by 4, which gives us a new matrix. That's going to give us 4. Then we're going to multiply 3 and 5 together, which gives us 15. We're going to add those later. Now we're going to go to the second column. So 1 times 2 is 2. 3 times 1 is 3. Let me add them. Okay, so now we're done with row 1. Now we're going to focus on row 2 and then multiply by column 1 and column 2 of the second matrix. So we're going to take 0 and multiply by 4, which is 0. And then 2 times 5, which is 10. And then 0 and 2, which is 0. 2 times 1 is 2. And then go ahead and simplify that. 15 plus 4 is 19. This is 10. 5, 2. So this would be our answer. Okay, so 17, apply the indicated row operations to the matrix. Okay, so this is row 1, this is row 2. And what it's telling us is that we're going to multiply row 2 by 2 and then add it to row 1. And that's going to give us our new row 2. So let's go ahead and do that. Here's row 2. And it wants us to multiply it by 2. So that's 12, 0, 2. And then they want us to add it to row 1. So 2, 5, 3. That gives us 14, 5, 6. And that is our new row 2. So 14, 5, 6. We did nothing to row 1. So it stays the same. And that would be this. Oops, I multiplied. That should be 5. Did you catch that? Okay. And number 8. So this is row 1, row 2. They're telling us to switch row 1 and row 2. So row 2 goes up here, and row 1 goes down here. That's it. So that would be this answer choice. A determinant will have a reciprocal, and the matrix will have an inverse if the determinant is not 0. So 10, how do we calculate the determinant? So for a 2 by 2, the formula to find the determinant of, let's say this is matrix A, you're going to multiply with A times D minus B times C. And what does that mean? So we have the general matrix A, B, C, D, right? For a 2 by 2, that is where we're getting our letters. So A is 5, so 5 times D, which is 1, minus B, which is 2 times C. We get 5 minus 6, which is negative 1. Okay, so now we want to calculate the determinant of a 3 by 3. So there's a really long process to do this, but I'm going to show you all the shortcut. And we get 1, 5, 2, negative 3, 0, negative 1, 3, 4, 6. And then we're going to repeat those first two columns. So 1, 5, 2 again, and then negative 3, 0, negative 1. Okay, so what are we going to do? So what we're going to do, we're going to find the first diagonal of 3 numbers. So like here, 1, 0, 4. And we're going to multiply those. So 1 times 0 times 6 is 0. And then we find the next one, which is this one. So 4 times negative 3 is negative 12 times 2 is negative 24. We're going to add those together. And then find the next one. 3 times 5 is 15. Times negative 1 is negative 15. And now we're going to go in the opposite direction. So here's the first 3. So 6 times 5 is 30. 30 times negative 3 is a negative 90. Okay. Let's move on to the next one. We get negative 1 times 4, which is negative 4 times 1 is negative 4 still. So minus negative 4. Last one, minus thing times a 0 is a 0, so it's minus 0. Okay, so let's simplify this. Right, with 0 minus 24 minus 15 plus 90 plus 4. And then that's just minus 0. Okay, type that into a calculator and you should get 55. Okay, so 12. Find the solution to the linear using determinants. I should have deleted this one. Okay, let me double check that. That should be deleted. That one is deleted, so don't worry about that one. And let's go to our last question. So this is your number 12. Determine if the matrices are inverses of each other by multiplying the matrices. So what that means is if you multiply a regular matrix with its inverse, you're going to get the identity matrix. And the identity matrix for a 2 by 2, it looks like this. Has the ones on the diagonal and everything else is 0. So we're saying when we multiply this, if we get the identity matrix, then they are inverses of each other. So let's go ahead and set it up. So same process. So 0 times negative 3/10 is 0. Negative 2 times negative 1/2 is 1. And let's go to 0 times 1/5, which is 0. Negative 2 times 0 is 0. And let's go to the last one. 5 times 3/5 is 3/2. And then 3 times negative is minus 3/2. And last, so 5 times 1/5 is 1. 3 times 0 is 0. We're left with 1, 0, 0, 1. So we do get the identity matrix, and so that answer is yes. Okay, so let's go ahead and go over our answers. So the first one is matrix, 2 is element, 3 is dimension, 4 is this matrix, 5 is this matrix, 6 is this one, 7 is this one, 8 is this one, 9 is reciprocal, 10 is -1, 11 is 55, and then 12, last one is yes. And that's it.